Hello guys, welcome back to my YouTube channel. So today we will be solving two very important and interesting questions from geometry. And as usual, these two questions are previous year questions from CAT 2004. And before I solve the questions, I would suggest the audience to read the question properly and give yourself ample amount of time to try and solve the question and then come back to the solution later. All right. So I will begin with today's first question. So in the adjoining figure, chord ED is parallel to the diameter AC of the circle. Okay. And O is the center of the circle. The angle CVE is 65 degree. Then find the value of angle DEC. DEC. Okay. So this is given as 65 degree, right? This is 65 degree. CBE. Okay, we have to find this angle. See, this is parallel, right? AC is parallel to ED. So I can say this angle, if I say this angle is X, I can say this angle will also be X. Why? Interior alternate angles. If two lines are parallel and is cut by a transversal, then the alternate angles are equal to each other. So these two angles form an alternate angle pair, so they are equal to each other. All right, let me join point E with the center. Now OE will be the radius of the circle, right? And OC is also the radius, right? If this is the center, OC and OE are the radii of the same circle, so they are equal. Suppose this is cap smaller, this is also smaller. If two sides of a triangle are equal, then the angles opposite to them are also equal. Okay, that means this angle will also be X. Now focus on triangle EOC, and suppose this angle, the central angle is theta. Can I say 2x plus theta is equal to 180 degree? Angles are property of a triangle. Now what is theta? Theta is 2 into 65 degree, right? Because EC is a chord. The angle subtended by this chord at the center is theta. There is a property of circle which states that the angle subtended by a chord at the center is twice the angle subtended by the same chord at the same segment of the circle, and that point should be on the circumference of the circle. Okay, so B is a point which is on the circumference of the circle, and this B lies on the same segment. Okay, so this theta will be twice of this angle. Okay, this is a property of circle. Okay, I will again repeat it. The angle subtended by a chord at the center is two times or twice the angle subtended by the same chord on any point on the circumference of the circle, given that the point lies on the same segment. Okay, from here I can say 2x, this will be 130, so 180 minus 130 is 50 degree, so x is 25 degree. Okay, I will again explain the solution. Since AC is parallel to ED and EC is the transversal angle, this angle, DEC will be equal to angle ECA, alternate interior angles. Join these points O and E, they will form a radius, and OE and OC will be equal because radius of the same circle. That means angles opposite to these two sides are also equal to each other. So this angle will also be X. Then I just use angle sum property of a triangle here. 2x plus theta is 180 degree, and I replace the value of theta by using property of circle. Okay, I have already mentioned what is the property. That is, this angle will be twice of this angle. Okay, so X is 25 degree. A very simple question. Let's move on to the next question. All right, so this is a very tricky and interesting question. Okay, so let's read the question first. And this question, by the way, has three questions. Okay, this is basically a set, and we have three questions in this set. In the adjoining figure, 1 and 2 are circles with centers P and Q respectively. Okay, so P is the center of the first circle, or I can say the larger circle. Q is somewhere here. Q is the center of the smaller circle or center of 2. The two circles touch each other. Okay, so basically they are touching here. So this is the point of contact of the two circle. Let me name these points. Not now. I don't know if this point will come in handy later. So let me think. Okay, points. The two circles touch each other, all right, and have a common tangent that touches them at R and S. Okay, so this is the point of contact of the tangent with the larger circle or with the bigger circle. This is the point of contact S with the smaller circle. Okay, this common tangent meets the line PQ at O. Okay, so they have extended PQ, and these tangents and PQ after extending meet at point O. The diameters of 1 and 2 are in the ratio 4:3. It is also known that the length of PO is given. What is given? PO. PO is equal to 28 centimeters. Okay. See, the ratio of diameter of circle 1 to that of diameter of circle 2 is 4:3. That means the radii of the two circles will also be in the same ratio. Okay. Suppose I will prove this. So this is D, the diameter, and this is small d. So what is d by d? This is given, right? This is given. 4/3 is given, and we know that diameter is twice of the radius. So I will replace this by 2r, where r, capital R, is the radius of the bigger circle, and I will replace small d by 2 into small r, where small r is the radius of the smaller circle. See, 2 and 2 will get cancelled. So again, the same thing, that is the ratio of the radii of the two circles are is 4:3. Suppose I take, let capital R is equal to 4x and small r is equal to 3x. Suppose this is the point of contact, right? So this is suppose P. So PT is equal to 4x, QT is equal to 3x. So this is 4x, this is 3x. I have to find the length of, what is the ratio, the length of PQ to that of OQ. Okay, so suppose I join this. I'm joining these 2 points. This will be the radii of the respective circles, right? And there is a property of circles that if you draw a tangent from an exterior point to a circle, then the tangent will be perpendicular to the radius of the circle at the point of contact. Okay, please focus on the word at the point of contact. So this is the point of contact, so this will be 90 degree and this is 90 degree, and this is the common angle between triangle OSQ and ORP. If I look at, I will write this triangle OSQ and triangle ORP. In these two triangles, angle SOQ is equal to angle ROP. This is because they are the same angle, or basically I can say common angle or slash same angle. And angle PRO is equal to angle QSO is equal to angle PRO. 90 degree, each angle 90 degree. Now in two triangles, two corresponding angles are equal. Two angles are equal to the other two corresponding angles. That means the third angle will also be equal to the third angle of the another circle. Sorry, not another circle, another triangle. That means these two triangles are similar. Triangle OSQ is similar to triangle ORP by angle similarity. So now this is the radius, right? This is also radius. PR is also radius, so this is 4x. And OS, not OS, QS is the radius, so this is 3x. So the since two triangles are similar, the ratio of their corresponding sides will also be equal to each other. So can I say QS divided by PR? From if you look at this order, QS divided by PR is equal to OS by OR, right? OS by OR is equal to OQ by OP, and we know that PR is 4x and QS is 3x. This is 3x, right? Because radius, and this is 4x. So can I say, if I replace the substituting the values, so from here I can say QS is 3x by 4x. So x gets cancelled. OS upon it. OR is equal to OQ by OP. I need to find the ratio of PQ to that of OQ. Am I given some length? I am given that OP is 28 centimeters. Okay, OP is 28 centimeters. If I have OP, I will get OQ. If I get OQ, I will get PQ. Right? Because, okay, yeah, see, now see, PO is equal to 28 centimeters. Given, substitute here. So 3 by 4 is equal to OQ by 28. Cancel this with 4. So OQ or QO is 21 centimeters. Now see, we are given PO is 28 centimeters. What is PO? PO can be written as PQ plus OQ is equal to 28 centimeters. What is OQ? We have found out just now, 21. So what is PQ? PQ is equal to 28 minus 21, which is basically 7 centimeters. What is PQ? If you look at the diagram, PQ is nothing but the summation of the radii of the two circles, right? Or you can say PQ is basically PT plus TQ, right? And what is PT? PT is capital R, TQ is small r, 7. What is capital R? Capital R is 4x, small r is 3x. So from here 7x equal to 7, you will get x equal to 1. So our second question gets answered here. Second question, what is the radius of the circle 2? Radius of circle 2 is 4x. What is the value of x? X is 1. So what will be the radius? Radius will be 4 centimeters. Okay. Now I need to find the ratio of PQ. Did I find the ratio of PQ? PQ is 7, right? PQ is 7. And to that of OQ. Did I find OQ somewhere? OQ is 21. OQ is 21, alright. OQ is 21. Just double checking with PQ. PQ is 7. Okay. PQ is 7. OQ is OQ. OQ is 21, correct. So the required ratio will be 1:3. So from this, two questions are answered. This is 1:3. Okay. Now I need to find the length of SO. This is very simple. SO is very simple. Why? See, what is OQ? OQ is 21. This length OQ is 21 centimeters, right? And this is 90 degree. Suppose this is Y. Now in a right triangle, I can say y square plus 3x whole square is equal to 21 square, Pythagoras theorem. Okay, y square, I need to find the value of y. X is 1, so this will become 9. So this 21 square is 441 minus 9. So what is the value of y? Y is SO, right? So this will be 432, root 432 centimeters, and y is basically your SO. So this is also answer. Very interesting question and not an easy question. Okay, I hope this video was helpful to you guys. For more such videos, do like the video and subscribe to my channel.